Let me pick out and averages. So we stop some. Good afternoon. Welcome to this segment. Last time we met, we talked about correlation, okay? And I believe that was clear. Today we are looking at a regression. Because correlation and regression will go somehow, it's not the same. We saw how it was last time we met. Today is also an application. That's what similar what we did before. We also calculate or do small definition of importance. Those of us online have said already. I know this kind of course, some more grammar, more calculation, as I said. So what we have to define something that is required. That's called regression. Regression. Already? Regression is a topic. Regression is a topic. Is a topic that considers regression is a topic that considers using regression is a topic that considers using the relationship of two or more variables considers using relationship between two or more variables for prediction. Using two or more variables for what? Prediction. Unlike last week, he uses the two variables to check how they correlate, whether it's positively, negative, or zero. For this one, we will look at the two and predict what will happen in the future. In this case, there is two variables. One is independent variable, and the other one is dependent variable. In most cases, the one is the dependent, while the x is the independent variable. That means y looks up to x to get the value. So that is difference here. I will use it to predict what will happen in the future. Is that okay? There's also what we call regression line. Let me also find out. Regression line is a best regression line, as if you are drawing a straight line, like we do some paths in correlation. Sorry, regression line is a best fitting line. Best fitting line. Not like saying I have something like this and I draw this. That's a line that will help me bring out gradient or slope. So that line becomes the best fitting line used for prediction as well. Use it for prediction.
Best what?
Use it for prediction. Types of regression.
Now you said it's what? Best what? Best fitting line?
Best, B-A-S-T, fitting fitting, F-I-T-I-N-G, fitting line, fitting line. Yes,
All right.
best fitting line for prediction. Best fitting line for what? Prediction. Is that okay? I can just say we have gaps, probably. Okay. Simple linear regression. I know that for this exam, you can't be up back. Cannot precise because that one is another method apart from this square method. That no. I just took X within line for you to actually you look at the variables and then draw the simple diagram. You know, you'll be thinking where it is X or Y. Then there will be a line of cross. This is the best. I want you to the eye to look at this line. That is best. Do not bother looking out. But the one will bother me, this square of calculation. But that is very. But types of one linear regression or simple linear regression. And that one uses one variable, just one, and just which you know that y is a dependent variable equal to a plus bx plus what we call e. Some will write it like this. Some will write it like this. Anyhow, we can write like this. But the write small e. This is called random variable. This is called next or random error. Why this one is the slope or the gradient, slope or the gradient. So this x is very oh, let me see. Independent what? Independent variable. Independent variable. Why this one is a y intercept where it is. So this line has but draw it here is a where it meets with the y. So this y is what x. And why this one is a dependent variable. So this is a simple linear regression. I don't know what it is. The other one, what about two? Types of regression. One, two, what regression? What is regression? We can have two. The user has mind, so we can have computer or Google Y because E E1 X1 plus E X2 plus E. And see that the variable here has changed that we have two independent variables. We can also have another day P1 X1, P2 X2, P3 X3. All these are not, but this is what we are expecting. We are not doing this because like students. This is what you see inside. Now there, right? Good. Like I was saying, I may give other names. I may give
Sorry, Mr. Vincent. Good afternoon.
I may
Mr. Vincent.
Hello, can you hear?
Okay, I can hear you. So I was trying to confirm. Can you,
Any question?
yeah, is it B3 is the highest, or you can go beyond B3?
So you can go down and go to any level. At this level, this is linear regression resident. But I mean that person I will see further is only because and even this one let there is expected value of so at the end we will remove and we get the one right? But the expected value of the what so this word of find data of find or what's and they find a can predict what will happen. Let's just do sometimes because sometimes in examination they may be using some language that looks as if it's difficult. There are two types of variables. Independent two. One, independent dependent variable, and this one is independent variable. We have agreed now that when it comes to the question, there are two types of variables. This is dependent, this is independent. And I can decide to use other names. They may call this one explain variable. Explain variable. They may call this one explanatory variable. This is explain variable. The other one is explanatory. They may call this one predict or predicted, and predictor variable. So this is the one, this one X, yes, predictor, and this one is the predictor. So you can see when there is a language, the kind of text you are in, so that you know which one is Y is independent variable, X is independent variable. This explains variable. This explanatory variable. This predictor variable. Because we're talking about regression, this is a regression variable. Another one is a regressor or regressor. This one is response. And this one is stimulus. These are other names you can give to us. This one is endogenous. The genus. And this one is exogenous. These are names. So many names like that. This one is outcome. And one outcome. Know that by the time you put it, independent variable. So we'll come and this one. That's out. Common is outcome minus covariant. 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 This one is control. Control variable. Because what comes from this independent control variable. Right? Finally, that is also control variable. In short, all these things are all what? So anyone who decides to examine picture, should read this way. So that one will right. Any questions so far? Any question? Now need to take question. We did a scatter diagram. And we did regression. So that's when it goes through that scatter diagram. We now have regression, let's with time. When we now put it something we now get the person. Nobody asks this square method. This square method of calculating regression. So this method we use this square method. So the scatter diagram that one is that square. See the function. There are two methods, scatter diagram, correlation. Second one is to use square, which is function. That's all that. I'm going to take the first question. I will do it together. See how it works. It works, right? I think it's a whole class. Let's say the third one is so I'll take the short one. Are you ready? Those of us online alpha. Oh, let me write the formula. We have seen the simple linear equation at the bottom. Regression is square. We all know is A plus BS plus E. That is done because it's going to be 0. So now we have to estimate what? The slope. The coefficient of x is the slope. So we have to estimate this. And we did a little of it the last time.
Hello, sir.
Yes?
Is this under least square? This formulas that I am writing down, is it under least square?
Yes, under least square. Another one is scatter, which you don't see.
Okay, sir. Can you move your slide small? Because that A plus B, there is something you wrote equal to A plus BX. That thing is not, we can't see those online.
Okay, you can see. Check this one.
Yes.
Okay. Okay, I write now. This is one.
Okay.
Okay. So this is A plus B X. You know that that one we saw before, which is the random error, where you find estimate of random error is 0. So that one is what? This is the equation we are talking about. So with this equation now, the slope is B. The coefficient of X is B. So this is the formula for equation of the strength. Where you find the coefficient of S is B. That is it. Some may even turn this B to beta. Some may turn this A to alpha. Whichever alphabet decides to solve is still the same. This is what the slope. And that is estimation of beta we're looking for. And how do you look for it? This is covariance of X and what? We studied that last time. Covariance all over SSX. You know this one? This one makes sum of square X, but something we will still learn to know this. Already this. And this one is variance from X. Is it okay? Abi, it's what you know. The other one was variance of X and variance of Y. Okay? And we'll find square root. But here, getting to slope is sum of squares of X. The same thing as variance of Y. And our formula has changed. Summation of X, Y, summation of X, summation of Y, all over N. Numerator now. Check whether it's that form, that's numerator. No, is the denominator that we just did. The denominator was X and Y. Variance of X by square root. But this one does not have square. It's just summation of X squared and the summation of X all squared over what? What you have done is the sum of squares of X. It is also called sum squares of X. SSX. Okay. So that in case you see percent SSX, don't forget this sum of squares of X, which is as variance of X. Is that okay? Good. So let's write the formula so that we can understand when we see the question. That is how to find beta. Well, you must have found B or the slope. The next thing is that you're going to find A. And one of the ways to find A because after finding B, you must find A to be able to get the equation of the regression. So for you to find A, changing subject of formula here is going to be Y minus BX, have equal to what? Have changing. So to put it, I want to now estimate what? A, it will be Y bar minus B estimate, already which we have done, B estimate, and X bar. Did you get that? Remember that the X bar means summation of mean, summation of Y. This one also mean. And you have gotten B, then we'll be able to find what A, so that we can form this equation back. Be able to predict what will happen to Y when X is known. Is it clear? Formula is working. Okay. Those of us are like alpha.
Yes, sir. That B is it the B that has cap? How do you call it? And the A that has cap? Hello, sir. Hello.
Mr. Vincent.
questions?
Mr.
So put it
Futher,
down. Let's
Hello,
take
can
the
you hear me?
question and see how we can.
I can hear you. I don't think you can hear us.
Hello, hello, can you hear us?
Already, question one for today. Or you have anything there?
Hello. Yes,
Everyone,
can you please
yes.
take the second
Okay, we're going to do that at the end of the class.
formula?
Question one. Those
Hello,
of us
can you please
online,
take?
question one. I just did small grammar and put person.
Yes, question, sir. Can you please
Question
take
one.
the second?
The data below.
Can you recite it, please?
Question number one. The data below represents. The data below represents the expenditure. The expenditure. Bracket open X. That means that expenditure bill is X. And the family income Y.
Sir,
Family income
I'm no
Y.
longer with you, sir. Hello, sir. Hello.
Recorded in thousands of naira. Recorded in thousands of naira.
Which question are you dictating from?
Recorded in thousands of naira. Of a sample of household. Of a sample of household selected in a locality. Selected in a locality. This is expenditure. This expenditure, which is X. This expenditure, which is X, is left in thousands, like this. This is a family income. Family income, which is Y, is also left in thousands. This is 5. This is 6. 8. 9. This is 7. This is 10. What's up? Yeah, good one. I said family. Okay, okay.
You can't hear them, they are talking.
I mean, this
Oh,
it has gone.
yes.
I had the battery. Yes. I had power off. What is the recording?
Yes, it's recording.
Is it recording? Is it recording, sir?
Yes, it's recording.
Okay. So that this is the movie service. Okay.
Use this one, let me connect.
Are you there?
So we can't see the board again. No?
Okay. So I will through the question. One more time. Let me try. I think it's the first question. No, it's not in it. There's no of such. There's no question that is there. Everyone will check. This one, most of the question that is there that they stated it. I mean, they stated it. They thought it was. Maybe they did. Okay. But that was grammar. The tabular form, and there's no, I don't think this one. No, this one. The ones they have there are just, they just pick some part of this. And there's no long question like this. All they did was to tell us summation of x, y, and z. That one is that. So, but we want to take it away. Those of us online, this is the question. This is data about family income and expenditure. The expenditure is the XIZ in thousand. The family income is Y. So according to this question now that I will put on the board, I want to calculate the family income, calculate the family income calculate the family income of a family whose expenditure, now we want to predict, whose expenditure is 3,500 naira. Full stop. You can see that after calculating the regression, we can now predict. We are predicting what the family income will be, what the family income will be when expenditure is 3,500. So that's what we use regression to do, to predict. And now with that formula now, we need x, we need y, we need xy, we need x squared, and that's what we're going to do. Is that okay? Solution to that our question. It goes like this. There is our x, there is y. There is 5, 6, 7, 3, 4, then 2. We have 8, we have 9, we have 10, we have 6. All these things we are doing is what we use to do research about things like this. Family income, we have seen the expenditure, we'll be able to predict what will happen. But before that, we need to set up the linear regression equation. And by setting that up, we need x squared. Because there's x squared in the question, the formula has x squared. So we need to get x squared. The formula also has, okay, summation of y, that one is there. It has xy, that's the only thing I believe. Another thing, there is xy, sum of x, sum of y, done. X squared. So that's the only, because when you see the formula, you now know what to do. Now that we have seen the formula, somebody help us. The one of y, the one of x. X squared, this is 25, this is 36, this is 49, this is 9, this is 16, and this is 4. Total. XY, this is 40, this is 54, I suppose, 70, 18. The one I'm doing on the board now, the figure is very small, it's small now, 5. Sometimes the figure can be large. We'll see that probably in second question. 4 times 4 is 16. You can see I didn't tell anybody to help me. But here, run the total. Total for x, total for y, total for x squared, total for xy. Is it clear? Good. It's just to know the formula, and you are there. Oh yeah, let's say the total. This is 27, Abi. Good. This FBA 840, I suppose. Let me write it to. Oh yeah, total here. 40. Uh-huh. This 39. Oh, 139. The next one. One nine four. Good. So our B, the estimate, will be summation of xy minus summation of x into summation of y all over n, all over summation of s squared, summation of x all raised to power 2 all over n. Is that? This one.
The last one is 204.
Okay, this is 204. Oh, yes. Good. That means here. So is that correct now?
Yes.
Good. So xy is 204. This is our denominator, the line of division. Summation of x is 27. Summation of y is what? All over total number 6, all over summation of s squared 139 minus summation of x is 27 all square all over 6. Is it clear? Any questions? Good. So put it down. I believe the calculator is still working.
Hello, sir.
Yes, I can hear you.
Now, please, sir, in this question, which one is dependent variable and which one is independent variable?
I thought you copied all this. Our X.
Yes, X is expenditure.
Expenditure is independent.
While is
family income, which Y is our dependent variable. Even sometimes in examination, if it decides to tell you choose anyone, make anyone dependent and make anyone independent. But in this case, our family income is the dependent variable because while expenditure is our Y is dependent variable, YX is independent variable.
But in reality, expenditure is depending on income.
Depending on income, yes. That's true. Yes.
Agreed. But I'm just telling you that in this question, we are making expenditure, which is our X, to be independent variable.
Income. Okay.
And the family income, you can even change this question the other way around. You can say now family income should be dependent. Are you following? But in this our question for now, anything. Because if I remove those things I put on top, we're working on X and Y, have it? And our Y is always dependent on variable. And why our X is independent. So anyone, even sometimes examination, you can tell you make anyone the way you want, whether dependent or independent. Your own is that as far as Y on this board is made to be what? Dependent, you work on it like that. Is it clear? Sometimes in real life, your expenditure sometimes determines what your income should be. Sometimes. For instance, you are earning an amount of money Are you following? And you now discover that what you are earning cannot fit in your expenditure. What do you do? That's your expenditure that is trying to be overriding your income. We push you to do more, to earn more what? Income. To be able to do what? Fit in the expenditure sometimes. And sometimes the income you have will also propel you to know what you want to spend. But one thing about economy which I remember, economy says clearly that even if you don't have an income, your propensity to stay to consume continues. Whether you have income or not, you will spend. True or false? So that's the tell you from an economist point of view. What you earn sometimes does not determine what you spend. You don't have money, you eat. It's just that the kind of food you eat, that one doesn't concern you, but that you will not eat is a lie. But your ability to save depends on your income. Are you following? Because if you look at the graph of income stuff, even at zero, you will spend. What is? Yeah, but that one I grammar. But one thing that propensity to consume will come first. An addition of the two must add up to one whole number. And you can only say when you have income. But if your income is zero, you can still eat. So sometimes your expenditure does not depend on what your income. That's the economic point of view. So if you are saying that your income will depend on this, it may change. Are you following? So that is just economic point of view, letting you know that one. Now, our result now, the estimate of what? B. We have 204. What's the result of that? 27 times divided by 6. Do one it? Okay, you have divided it. Okay, the down one, 136, 139, 27 square, 27 square. Okay, the answer is 1.5. Oh, you have done everything? No, I want us to see it quickly.
121.5.
Okay, this one is this one 121.5?
121.5. Yes.
Okay, 121.5. This is the result now, right? So numerator, what do you have?
24.
24. Over
17.5.
Over 17. We have
1.3714.
1.37. There's one here.
1.14. 1.4.
Okay, 1.4. So okay, let's still leave it. Let's okay, let's just leave it. Now we have gotten the slope. Now to get A, to estimate A is going to be Y bar minus B estimate X bar. What that simply means that this is, let me write it very well so that somebody will understand. This is it, Abi? Yes, so that in case some do not understand. And this one means summation of X over N. So that's the result. And why this one is Y is 40 divided by 6. This one is 1.3714 into 27 divided by what? 6. Our result here, what do you have? Are they still there? Is the calculator doing well?
It's 7, approximately 7 or 6.7. 6.7.
6.7.
Yes.
Yeah, 6.7. Yes. Then this one is okay, this one is okay now. Okay, anyhow, no, but what are you doing here? What's this one? 6.667. Let's say that is, I mean. Okay. Okay, because I use. Okay, I agree. Now this one is okay. What's the result for this? 5 or no 4 point something. 4.5. Exactly 5 erudite. Okay, that one is better. So this one is 6.6667. I have multiplied it. 1.3714 times 4.5.
6.1713.
6.17.
1713.
Okay, 13. I have subtract. What do we have? Okay, 0.4954. Abi? So that is our intersection. Y intersection. Is that okay? Having seen that, we can now. You got something else? They are making it 4 figures, 4 decimal. Abi? This minus this. Or were you approximating? Because we are trying to base 4 decimal here, 4 decimal. This one was 4.5. So you are using 6.7. So the level could make everything, but there's that one doesn't make. But our regression equation is as follows. So y is equal to a plus b what? X. Y is equal to 0.495 plus b is 1.3714 times what? X. That's our regression equation. And the only way you can get regression equation.
954. 4 is omitted.
Okay. Thank you, guys.
954 since we are using 4.
Let's just leave it like that. It's okay. Thank you. Now, this is our regression equation. Without this regression equation, we cannot answer that damn question that say we should find the family income when the expenditure is 3.5. Have it? So, and that means to say that we cannot say family income 0.4954, 1.3714. Family expenditure is 3.5, have it? Good. So we can now predict the family income, which is y, and this should be, you can run it together. Okay, let's take it easy, 49 plus, what is this one? 4799.9. Okay, so y addition of the 2, so that we can now get to the last value. To add these two together. 4799. Okay, 4800 exactly. Like this, Abi. 0.3 something. Only 2 decimal. Because it's money. Okay, 0.4. So that means the family work income should be higher than the expenditure, Abi. So you can see now that we are predicting, because the family income should be higher. So with this now we are predicted that they need a family income of 4,008 to be able to meet an expenditure of 3.5. Just like I told you, your expenditure will prepare you to increase what? Your income. Your income will also prepare you to make sure you spend what? Less. So whichever of the two can be our prediction. Is it clear? Let me see that past question where there's anything that relates to anything like that. Is it this one? Okay, let me just where I can pick something there. If there's any. Okay, it's the objective I'm talking about. And it's always at the back. You know, before they put theory. But the objective that if I can see if I have X and Y, okay, so we should do it.
I think MBA session.
Okay, MBA session is okay. Are you sure? They don't write so many. Sometimes what they are after is that there's even mathematics, statistics. The own is that the question relates to what sometimes we want to do. Use the following to answer necessary question. The following are some observation made from laboratory of respect of pair of variables x and y. This is a good one. So let's see this one. This one is objective as well. Which year is it? Let me know. That's a good one. So we're looking at past question 2005, 2006, 205, 206. We're looking at the first one I saw there. Question number 53.
Please, can you share the question? Can
we share?
Yes, the question.
Okay, somebody can.
Oh, I mean on the platform.
Share?
On the platform.
On the platform, can you share? Just snap this place, that page, towards the end. You can just snap and send to the platform so that we can see whether we can remember what we have been taught, both the past and present. Because correlation and regression, they go hand in hand. There's still another one we're going to see there.
Hello, sir. What year is that?
2005, 2006. But they will send it to the platform now.
Okay, sir.
53, 52, 54. So let them send it. Let's read that one. Now that we have known correlation, we have known regression. So let's see how we can apply it on the board or how to sort it out in examination. So if you look at that question very well, is what we have done. They gave us two variables, x and y, have it? In that variable, they have to refer to this. They refer to our regression equation. They say given the model, the regression model or equation, whichever grammar, that it is y equal to a
Question what, please? Question what?
Question 53, 54, 55. Is that okay? 53, 54, 55. Because they say we should use that information to answer the next three questions. So like I was saying, we are given x variable, y variable. When you are given x and y variable, it is obvious that y from their model, y is dependent, y x is independent. You don't even need to ask question on that one. So we are asked to find the intersection, which is the constant. That constant is alphabet A, the one that does not have x attached to it. Number 54, they say we should find the slope, which is the gradient, Hello? And you are aware that we can solve 53 without solving 54 first, So let's go to 54. It's still the same idea here. What we have here is not different from what we have just solved now, but we have to just practice the past question so that somebody will know what they give you. Maybe that time, maybe now if you don't repent, but still make things faster in your own way. So we have here solution to that past question. We have x, we have y. X is 10, 35. 3 But 8, 38, 15, 15, 10, 32. I hope it's correct. Total, we need it. Total, we need it. X squared, we need it. XY, that's all we need. That's all. X squared is 100, abi? 9, 64, 225. Is your calculator doing justice to that? Is it clear? I hope we are all doing it. Those of us online, I hope you are getting this thing. At least we just did it now. You can practice it yourself. There is 120. Somebody help me press calculator. 8 times 38. 8 times 38. SY. At least I've done 10 times 3, 35. 3 times 40. 3, 304. What's that? Okay, 15 is 225. Yes, 225. This is 320. And I believe they can run this total as fast as we can. Number 54. 54. There was 53. But you can only get 53 when you have gotten number 54.
XY 1319.
13, 19. Then X square 498. Okay, 498. Y 160.
Say, hello, the person comment. Alright. X 46. So this question we are going to take. But just because we have seen it in your passport, you want to do it. No influence on it. So how you will run all this, I don't know. But you have to be very fast. This is your calculator. So we have to find P, which is the slope. That is the slope, which is a covariance of x, y, and the variance of what? X. So here is summation of x, y, and the summation of x into summation of y all over n, all over summation of x squared, summation of x1 squared, all over n.
We can't see. We can't see. Those online cannot see.
Every come has come for them, see they can't see. Can you see now? So they can't see after it's not deteriorating our network. It's not everything. It's not everything. They can't see. It's right. So we have a summation of x, y, 1319 minus summation of x, 46 into 160 all over 5 over summation of x squared is 490 minus summation of x 46 all square.
Can you please move the board? Can you move the board by the left more?
Okay.
Can you move the board, please, to the left?
Hello? What is it? Maybe I just.
Can you move the board to the left so that we can see?
And you can
It's
see
okay
it now.
now. Yes.
Uh-huh. Okay, somebody help us. Here's a 1319. The result of that for 6 times 160 divided by 5. What do you have? One four seven. 147. Are you sure? 6 times 1. Divided by 5. 147. Why have a negative? Are you sure? Okay. About to see that. There's some. Come on. 4 square. Okay. There's negative. 4 what? 23.2. So the upper one is minus a bit. Minus what? Minus 153 all over 74.6. What's the answer? 2%. Yeah. Minus 2%. 45. 0.5. Good. Our answer is what? B. Number 54. The answer is, and that is 4. And to solve 53, which is A, is equal to 5, which is Y, minus B estimate X bar. Our Y, which is summation of Y minus 2.415 into summation of X by N. Y is 160 divided by 5. This gives us 2.25. X is 46 divided by 5. Preserving us 160 divided by 5. So that is the 30 and 12. Good. And this one, that should be 9.2. 9.2 multiplied by this. 9.2 1.1 18.1. Add it together. 50.1. That was the number 50. The answer is G, TRA. So this A is the constant on the Y interest. Is it difficult? But once it's like that, we are already got it. So this we need to solve it. 55 we're done, or we should still try it. We should do it no problem, just ask. There are no something of the that's all the things. It's not that okay, it's not wrong. Yeah, something like that. Okay, this one is from yes, active.
Yoruba. Okay. They get the clipper.
Hello?
He did back when he came back.
Are you there? Can you hear me?
We can hear you, sir.
Pearson's coefficient and correlation coefficient. Pearson's formula is always empty. Unlike Spearman. The Spearman is very short. And that means we have to include here, right? We have to include a y square. I agree. Because there's y square. So these are y square. Okay. This one is not math. This so that's number 53. Objective answer is B. 53. Answer is B. 5. And see what the result will be. 53. 5. 54 is 3, 4, 5. This one is a Pearson's correlation or relation coefficient, which is written as R. That is a Pearson's correlation support, which is a covariance of xy all over square roots of variance of x, which is remember, variance of x is written as SSS. Are you following? Variance of y is written as SSY. In case they decide to fix it in that way. This variance of y. Is that okay? So the formula is not straight. Multiplication. This one is summation of xy and a summation of x into summation of y. All over n. You know, this numerator we have done it. You know, in examination we have done the numerator. It's just the denominator and we have done one part of the denominator, which is summation of x. So we just put this in right perspective, summation of x squared, summation of x all squared by n. That's for this into summation of y squared. This is only what we have not got for all over n. So automatically the result of top here was minus. Yes, a minus 1 to 300. Because they don't expect you to start on right. Expect to, write on formal proof or a system. So this one, we also sort out this, and it was this 71. We don't put out 7.8. Is the other one where we have summation of a y square less than that was the bunch. So x y square. Yeah. 35 raised to power 2. 35. 12, 25. Then 40 square. 16 and 0. I mean, 38 square. 14. 44. Then 15 square, that one is 5. 32 square, what that? 92 square, 10, 24. Yeah, run this for us. Run the total. $55 18. Good. Now, we'll now start with this. Summation of y squared is 5, 5, 18 minus summation of y is 160 all squared over 5. So all we just did now is over 1 minus 1 over the square root. This is 74.8 times. So help me run this. That was the time. 160 squared divided by 5 is 120. Then it's 120. That means 5 5 is 120. You say not 120 and 3 9 8. So the thing is somewhere out. So from one division, 1 minus 158 over multiply these two and find the square root. This times this, find the square root. So I will just put it on there and then the result. 5 4 5 6. Everything is square root. 5 4 5. Okay, 5 4 5 6 2 6. Point 5 4 5 6 2. Okay, nice. Okay, 2 2 6. No, 6 2 2 6. Like this. See like this? Yeah, what's up? With that. Okay, when you divide. Okay. Minus I mean. So is that so it's opposite. So yeah, let's watch it out.
Times 39.
Each time.
29 7.
Okay, this divide. This 170 square. Divide by 5. Is that 5 1 2 7?
Yeah.
Then this minus this.
Class.
Okay, there's something. So here is minus 1 over this times this time. Square root 1 1 5. Minus. It should be minus something.
Minus
0.8867. That is 8867. That minus the power. Okay, there's no. Okay, it's B. 8. Okay. E minus 0.8867. So the answer here is what? E. So you just have to take your time, follow the rules, and the answer will not change. We'll try one more passage on there. Then this one, also this one. That's same year. Help me snap number. Those use it to answer. Okay. Use it to answer two questions. So help me snap from 15 to 17. Send to them. To solve that one. This one we're not calculating. They are already done. That type will solve in that case. Let's have that. See whether some of us will understand how to see n. Because when it's x, you can easily count. So it's 5. But when they have put this question for you, some may not know. Let's see that is try correlation, regression. No. So that when next we meet, your exam is members for this exam. Oh, it's not easy. That's 16, 17. Just snap on that team so that I can cover it from team to where we have done that 15 per day. That 15 was probability 1 time. But we just snap that 15 to 70. Just so you can just run it after I do that. So that's 200 probability sum and hypothesis. And 1 error, 2 error, now hypothesis. That should be 2 next. That's it. That's in the program. Let's check analysis of errors. Alpha. Anything like that? They mentioned it like that. That's possible. I believe there's only 2 we have started with 2. Sean. Let's just to understand this way of this. Maybe what you say. That is fine. All those tools. The current question, not only the question that was asked 2 years ago. Everything hiding as if it's more special. But now, where somebody I know what I'm saying that is what is of is to look at that you should have access to having not the full structure. Because this one you are seeing is when these are big mathematics department seconds. The question that was science and the one said. But that can not so mathematical statistician drawing that was so we have seen that. So this one I will not stress. Okay, please. Those of us online, any question? Are you still there? Are you still there? Those of us online, have you seen the question? The first question,
Yeah, still there.
2005, 2006. We're going to take care of number 15, number 16, number 17. Then by His grace will be, calling it. Yes, so. Can I go ahead? Yeah. So, according to the question, let's have it. So that just go ahead and answer. Find them of God. Is to get it more clear. That number 15 is 2005, 2006, past past. Number 15, that one centers of probability and our knowledge of self that relates to probability. In a simple language, probability of A union B is always equal to probability of A plus probability of B minus probability of A intersection B. That's the formula. Anytime in A, probability of A union B is always given like this. And the question was so clear. It said probability of A is 0.16. The one further again, probability of B 0.7. Probability of A intersection is what we're asking. And probability of A and B
Hello, sir. What
was
number is
0.8. Even if one does not.
Sir, number what, sir? Question number what?
So, look at the board. This board, and move it to the left-hand side.
Number 15.
Hello, sir.
1, 5.
Intersection 1 equal to 0.6 plus 0.7 minus 0.8. This is my problem. This is 1.9. Okay, somebody, don't listen. This. What do you have?
Question what, please? Question what, please? Question what?
What do you have?
Question what, please?
So 0.5. Good. So and that answer there in the question is that should be C. Good. Number 16. We're asked to find the slope, Abby. This question is on regression. And we're given summation of what? XY on the board. We're given summation of XY. We're given summation of X. We're given summation of Y. We're given summation of S squared. And the question made us to understand that I starts from 1 and stop at what? 6. That's 6. 6, are good. That is our end. Is 6. So everything. So this is slope. Summation of xy, summation of x is the summation of y all over n, all over summation of x squared, summation of x all is equal to 9. Therefore, the question gave us summation of xy. How much? Or what's the value? 108.28, I mean. Summation of x 34.30. Summation of y. If you have not gone through regression, you will know what this. Because you have gone through it, that's why they give this, you'll be able to know what to do. So that is important. I've tried making summation of x squared. That is 238, that is 238.9. Then summation of s is already s. 3, 4, and 3, 0, or is by 2, or 5 by 6. Is that correct? Any question? They gave us what is it? They even gave us summation of y squared. Abi? In that question, there's some y squared. Yes, y squared. Have you seen it? Okay. So confuse somebody that does not what he's doing. So that summation of y squared is not relevant to the final word slow. But it will only occur if you understand the formula before. Because only we say for them, it should be relevant. Yeah. Except if we are finding correlation. So that's what's the result. I'm not just wrong. This is number 1081. Okay, 28. Okay, this time 6 divided by 6. What do you have? 123.5. That's the numerator. The numerator here is 238.69 minus square this divided by 6. What do we have? 196.08. So the numerator is up. That's the minus of minus what? Minus 15.25 over. So this one is plus. What do we have? 42.6. Divide it. Minus 0.2. Are you sure? You slow. I'm not going to tell you. So that day we got the answer. That Friday we got the answer. So does that mean you are planning something? That's what it. Slope of regression. No. Summation of x, y, on weight. Summation of x, 34.30 times 21.10. Okay. Here's 10. I mean, that's 10. That's it. So then that of x squared. Okay. So we need to be careful how you are picking the values. So there you go. So that's the answer. It's 10. So help us to recalculate that up. This time 6 divided by 6. 120.6. So subtract that up again. Minus 12. Okay, 12.4. I believe this time is okay. Divide, let's see. Over it. Either B or C. That's what I want. 28. Okay, we can still manage that. 2897. Yeah? So we can still manage that. 2897. Or 9 what? 3 again? Yes, 9. Okay, you can still manage this one. And value is close. 979. Say so many parts. That one has gone. Finally, A, the estimate of A is Y bar minus estimate and X bar. The question gave us, so this is the summation of Y over N. This will be minus 2893 into summation of X over N. One indication, summation of Y is 21.1. 21 all over 6. This will now be plus, minus and minus. Now have 2893 minus
It's 0.28. 0.28.
0.289 into summation of X is 34.8. Okay. Divided by 6. So result here what we have. Divide this, multiply by this. Yes, now 70.51767. Okay, plus divide this, multiply by this. No minus minus. So divide this. Those of us on one are you still there? I'm not hearing your voices.
They are still there.
I'll say that. That's 1.65. 1.65. 38. 38. Like this. Divide this times. Result. Or something. Or is it 5? 5 something. 5 point something. That's the cost. 5.17. 17. Yes. Have something there. Exactly. 5.17. Any questions? Those of us online now, any questions? Who is not clear?
Hello, sir. So is it only number
We can say clearly
that we solve?
for correlation, regression, analysis,
or 17
we
is
are done. Just 2 more topics like this to conclude the constant time words. And we are solving questions, which means we're already doing it. On that note, those of us online, if you can hear me, that's all we can take for today's class. On that note, God bless you. See you when it arises. Bye for now.
Okay.